Assalamu-Alaikum dear students. I am Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will discuss Baeyer Villiger oxidation reaction. In Baeyer Villiger oxidation reaction, carbon-carbon bond which is directly attached to carbonylic functionality of ketone will be oxidatively cleaved. For example, open chain ketone will be converted into ester and cyclic ketone will be converted into lactone. This reaction carried out in the presence of oxidizing agent like peracids such as MCPBA or hydrogen peroxide. And this reaction is also carried out in the presence of acid. This acid may be Lewis acid or protonic acid. For example, look at the example here. R1 is directly attached to carbonyl group and R2 is also attached to carbonyl group. When it is reacted with peracid or hydrogen peroxide, as a result, the final product in this case is ester. In both these, R1 and R2, one of the group will be migrated to oxygen atom. For example, R1 and R2 in this case. If R2 is bulkier than R1, then R2 will be migrated to oxygen atom and this type of ester will be formed. And if R1 is bulkier than R2, then what will be the structure of the final product? The final product will be like R1 is bulkier in this case, so R1 will be migrated and R2 will be like this. So this type of ester will be formed. So the migratory ability depends upon the structure of the substituent attached to carbonylic functionality. So the migratory aptitude will be like this. Tertiary alkyl group will be migrated first, then the cyclohexyl, and it is much more than secondary alkyl, which is then benzyl aryl. And in case of aryl group, for example, if we compare phenyl and methoxyphenyl, so here in case of methoxy group, it is electron donating group. So when electron donating group is attached to the aryl functionality, then this will be migrated first, then the phenyl group. So the migrating ability will be like this. So at the end, primary alkyl and then methyl and hydrogen. So what will be the mechanism for Baeyer Villiger oxidation reaction? Let's have a look to the mechanism. This is the starting material ketone. This ketone is reacted with acid. In acidic condition, carbonylic functionality or ketone functionality will gain one of the proton and it will become like this. So the positive charge will be appeared on carbonylic oxygen and this is stabilized by acetate ion. In the next step, if we compare this ketone and protonated ketone, now both of this is present in the same reaction mixture. One is the simple ketone and the other one is protonated ketone. So in case of protonated ketone, here it is much more positive. So electron or negatively charged species or any species having electron, much more electron, will attack on carbonylic carbon having proton or protonated carbonylic functionality. So in this case, per acid will attack on the protonated carbonylic functionality and the bond will be break towards oxygen atom. As a result, alcohol will be produced. Here, oxygen with positive charge. In the next step, what will happen? This proton will be removed and this structure will be formed. In the next step, when alcohol lost this proton and pi bond or double bond will be formed in this case. As a result, if we look at the starting material, here one of the structure is cyclohexyl group and the other one is methyl group. As we discuss about the migratory aptitude of different functionalities, so the cyclohexyl or secondary alkyl group migrating first, then the primary alkyl group. So this one is secondary and this one is primary group. So cyclohexyl will be migrating to oxygen atom and this one will not. This methyl group or primary alkyl group will not be migrating. So in this case, when pi bond or ketone functionality is regenerated, this alkyl group or cyclohexyl group will be migrating towards this oxygen atom, and as a result the bond between two oxygen atom will break toward this bond, and the carbonyl functionality or the pi bond of this oxygen atom will cleave toward oxygen atom. So what will be the structure of the product? So this will be the structure of the product. As you can see here, the cyclohexyl group is migrating towards this oxygen atom. So this type of ester will be produced, and this is the byproduct. Let's have a look to some of the example using Baeyer Villiger oxidation reaction. When this substrate is reacted with MCPBA in DCM as a solvent at room temperature. So look at the starting material. Here one of the functionality is ketone and the other functionality is amide. When two such type of functionality is present in the same starting material and when it is reacted with MCPBA or Baeyer Villiger oxidation conditions, so the ketonic functionality will be oxidized and this amide functionality will not be affected. As you can see here in the example that the oxygen is inserted in between this bond, and this amide is not affected. So 100% of the product is this one and none of the product is this one. As we discussed earlier that the tertiary alkyl group is much more migratory aptitude than the secondary one. So here only the tertiary alkyl group is migrated towards the oxygen atom, and this cyclic structure or secondary alkyl group is not migrating to oxygen atom. So this is the only product. In the second example, as you can see here, carbonylic functionality is present and lactone functionality or ester functionality is present here. When such type of reaction or subtype of substrate is used for the Baeyer Villiger oxidation reaction, so what will be the product for this reaction? As we discussed in the first example that ketone will only take part in the reaction and amide or ester functionality will not be affected. So also in this case, when in the same reaction mixture or in the same substrate, ketone functionality and ester or lactone functionality is present, then the ketone functionality will be oxidized and lactone functionality will not be affected. As you can see here in the example, here this ester is formed and the lactone is not affected here. If we compare the structure or the substituent attached to this carbonylic functionality, one is methyl group and the other one is this secondary alkyl group. So in this case, this secondary alkyl group is migrated to oxygen atom and the methyl group is not. So this one is the migratory structure and this one is the final product. Have a look to the third example. It is also two types of functionalities here in this third example. The one is ketone and the second one is ester functionality. When it is reacted with MCPBA in the presence of acid, so what will be the structure for this reaction or what will be the final product for this reaction? As we discussed in both of these examples that amide and ketone functionality will not be affected, so here this one will not be affected. So now the question is either this functionality will be or this group will be moved towards oxygen atom, or this group will be migrating to oxygen atom, or this group will be migrated towards oxygen atom. So in this case, the aryl group will be migrated because it stabilizes the positive charge or carbocation and Due to this reason, this aryl group will be migrated towards oxygen atom, and this type of ester will be produced. And the other thing is, none of the product with this alkyl group in between this alkyl group oxygen is not present, and also the ester functionality is not affected. I hope you learn well from this Baeyer Villiger oxidation reaction, and if you enjoyed the videos, please like and subscribe my YouTube channel, and also share the videos. Thank you so much. The Allah Paman.